Okay, this is our final video of the day, and this is about sewage treatment. All right, we have to describe characteristics of environmental concept, processing model, or model represented visually, and that's what we're going to be talking about is sewage treatment plant. There are many components of a sewage treatment plant that we need to understand. Primary treatment of sewage is the physical removal of large objects, often through the use of screens or grates, followed by the settling of solid waste at the bottom of a tank. So we're getting rid of the solid objects. We still have dissolved things in here. So we have secondary treatment is a biological process in which bacteria break down organic matter into carbon dioxide and inorganic sludge, which settles to the bottom of the tank. The tank is aerated to increase the rate at which bacteria break down the organic matter. So we're adding oxygen to encourage aerobic digestion. And then we have our tertiary treatment. It's the use of ecological or chemical processes to remove any pollutants left in the water after primary or secondary treatment. And prior to discharge, the treated water is exposed to one or more disinfectants, usually chlorine, ozone, or UV light to kill any bacteria. Okay, so first step, you need to know these in order and what they do. So sewage, it's waste, sludge, anything that goes down your sink or your drain, goes down the bathtub, toilet, all that stuff. All right. And forgive me if I sneeze. I feel like I'm going to sneeze any second now. Physical removal of large debris like toilet paper, leaves, plastic, sediment with a screen or grate. So first thing, let's just get all of the solid stuff out. Second is secondary treatment. It's the biological breakdown of organic matter, that's feces, by bacteria, and any other organic substances. It's an aerobic process that requires oxygen. Okay, so we're breaking down that organic matter. What's left is going to be our nitrogen, phosphorus as well, and bacteria. So we can't release this water into our ecosystems unless we make sure that we remove solid waste, make sure we break down organic waste, make sure we remove nitrogen and phosphorus to prevent eutrophication and any other bacteria. And then we have disinfecting, right? Any viruses or bacteria that may be present in this water, we use a UV light, ozone, or chlorine to kill bacteria or other pathogens, such as E. coli. It's really considered part of tertiary treatment. So this is a really central step right here, okay? When we say effluent, we say liquid waste or sewage that is discharged into a surface body of water, typically from a wastewater treatment plant, okay? So if we say effluent, it is liquid waste discharged into a surface body of water. And we want to make sure that we really don't consider it sewage by the time it goes through these three: primary, secondary, and tertiary, okay? So let's talk through here. We have screens or grates, all of this muck and stuff. We need to filter this out. So as wastewater goes through here, we have screens of different sizes to collect this material. All right, and then we have a grit chamber that allows sediment like sand or gravel to settle out. So we have these grates that collect this material, and then we have a settling pond where sand, silt, probably not clay, but sand and silt will settle to the bottom, and this gets extracted. But the waste, the water, continues, okay? We have oxygen is bubbled into an aeration tank that is filled with bacteria over here during secondary treatment. So we have our primary clarifier. This further takes raw material and sludge out. And then we have what really looks like surprisingly fairly clear water. It's still dirty and gross and disgusting. But a lot of the solid material, either through grates or through settling grit chambers or clarifiers, which are we add chemicals to clump these materials together and have them settle out even further. And then we usually incinerate this or dehydrate this before we send it off to a landfill. Here, this water, we have a lot of waste that is still left over. And so we add bacteria and we add oxygen to this aeration tank. Oxygen and bacteria are the fantastic ingredients that help break down this waste even further. So we have an air compressor. All right, so we're going to break down this waste using bacteria, and we're going to provide them with all the oxygen they want and need so that they can continue to break down this material, okay? turns it into carbon dioxide and nutrients like nitrogen and phosphorus. We also have a secondary clarifier in case we have any other materials that are solid enough to sink to the bottom. We collect this down here, and we can recycle this as needed. All right. Secondary treatment removes 70% of phosphorus and 50% of nitrogen. Doesn't remove persistent organic pollutants such as medications or pesticides. So that's an important thing to note. But this will remove phosphorus and nitrogen. All right. I've mentioned sludge. It's inorganic solid waste that collects at the bottom of tanks. Primary and secondary treatment. Water is spun or pumped off to concentrate it further. All right, and the dry remaining physical waste is collected from a landfill, burned, or turned into fertilizer pellets. That can happen. Now, after primary and secondary treatment, some plants go directly to disinfectant. Oftentimes, the problem with going directly to disinfection is a lack of funding for smaller municipalities. So that is one of the biggest hurdles for a lot of wastewater treatment plants being able to continue this process to fruition, right? So, disinfectant, UV light is very effective in killing any bacteria. Ozone and chlorine as well can kill that. And the ozone and chlorine eventually will evaporate out the water. This discharges into surface water, right? Our lakes, our streams, our ponds, our rivers, while some will use tertiary treatment to remove even more nutrients before discharge. Okay, so disinfection is part of tertiary treatment, but we want to make sure we remove as much nutrients as we can because we don't want eutrophication to occur. All right, so tertiary treatment. We're using chemical filters to remove more of the nitrates and phosphates from secondary treatment. All right, so the critical step, because effluent that is discharged into surface waters with elevated nitrogen and phosphorus will lead to eutrophication. So this will eventually get rid of all of our nutrients, right? Or not our nutrients, our oxygen. Too much nutrients will lead to hypoxic conditions. So water from secondary treatment will go through a trough right here. It's expensive and not always used, right? And so we'll have an extra filter right here, a filter tank, in which we help clarify this water. Okay. So what are the issues with this? Combined sewage and stormwater runoff systems can cause waterways, wastewater treatment plants to flood during heavy rains. And that means that this water is going to bypass this process and go directly into surface waters. All right. So if we have combined sewage and stormwater runoff, we have our city right here. We have our sewer drains, and then we have our storm drains. So we have extra heavy rains in the summer. This can flood, and we're supposed to have this flow into a wastewater treatment plant. All right, so we have our overflow structure right here. We're not supposed to have more sewage than this, but if we have rainwater, this will elevate and this will go right into our river, stream, lake, etc. So stormwater runoff can be pretty bad, which is why it's especially important to have permeable surfaces and green roofing to prevent extra stormwater runoff, okay? Beneficial because it treats stormwater runoff normally, but causes overflow during heavy rains, all right? And so this, stay away, all right? Raw sewage releases contaminates surfaces with E. coli, ammonia, nitrates, phosphates, and endocrine disruptors from medications, okay? So typically you can spot, there are websites that determine the health of your river systems. The James River has one such thing, that you can check to see how many E. coli colonies have been detected in the river system. If it's low, it means it's usually safe to swim in, but if it's high, that usually means we've had an excess of stormwater runoff moving into the James River. After a heavy rain, I would probably advise you to check the health of whatever river you're going into. Look for E. coli, and maybe wait a few days before jumping on in there. But yeah, the rivers can be safe, but after a rainfall, definitely check. Even treated wastewater effluent released into surface water often has elevated nitrogen and phosphorus levels and endocrine disruptors. These are medicines, again, as we mentioned, that pass through the body. and inhibit hormones from acting properly or mimic hormones. And so it encourages certain responses that your body isn't really interested in. Okay, so identify a number on the waste treatment diagram below that represents a step in primary treatment. All right, well, describe a pollutant removed by this process. Okay, well, we have our great system right here. Okay, and as what we do is we're collecting solid waste right here, and we are moving this through. So we'll say 1, but 2 and 3 as well. This is a settling tank as well to help get more solid waste. So all of this stuff, this is our settling chamber, and this is our grate chamber. So what we're going to do is we're going to remove solid wastes, dehydrate them, incinerate them, and send them to our landfills or turn them potentially into fertilizer pellets, depending, right? But there could be plastic. This is a lot of tissue, toilet paper, anything, diapers, all sorts of crazy things can be found within here. And so we're preventing this from making its way into our river system. All right, that's what I have for you for wastewater treatment plants. These are point sources of pollution, keep in mind, and I'm going to go back here because we had discussed this earlier. Point source of pollution are sewer outfall and our treated water. Both of these can be point sources of pollution if this isn't treated properly, or if we have an excessively high rainfall. All right, and that's it.